Welcome to this Maths Made Easy video on arc length and area of a sector. And first we're concerned or taking a look here at arc length. So let's use this diagram to help visualize the arc length. So if we start here with our point in the center, and we take this point from the center and extend this here to a point on the circumference, then the length we obtain here simply is the radius. And we can also see that here from, again, going from the center here to this point here. Again, this length will be equal to this length. They are both equal in length and they're both the radius. We also obtain this angle that's formed between the radius here and the radius here. And this angle is theta. And if we've got the length here r and we've got the angle theta, we can simply obtain an expression then for the arc length L. And L is simply given here by the radius r times by theta. So r times by theta, r theta. It's important to note here that theta must be measured in radians. So theta is measured in radians. Now we can simply extend this result here for the circumference. So for the circumference then of a circle, we would simply set theta being equal to 2 pi. Remember, theta is measured in radians, so if we want the full 360 degrees, then that's 2 pi radians. So therefore, using theta equals 2 pi, in this case then, the length, or the arc length here, L, is simply given by r theta, where theta is 2 pi. So this is r times theta, which is 2 pi, giving us 2 pi r, which we know can be used for the circumference, or the arc length here. So this should be the circumference, sorry, this is C. So this is the circumference C here, which is 2 pi r, or you could write that as pi d there. Okay, pi times the diameter there. And that result just simply shows how we can obtain the circumference there, using our formula for the arc length. Moving on now to the area of a sector. And again, we're just going to take a brief look here at this diagram just to help us visualize the area of a sector. So if we take this point here as our center, we can extend from the center to a point on the circumference here to give us the radius. And clearly this length here will be equal and will also be the radius. We have this angle subtended between these lines, which is theta, and using theta and r here, we can actually obtain the area of this sector. So the area of a sector is defined as A being equal to a half r squared theta. Okay, this formula here gives us the area of a sector. It's important to note again that theta is measured in radians. So theta is measured in radians. Now we can also again extend this result here for the area of a circle. So for the area of a circle here, using the fact that theta must be equal to 2 pi if we want the area of a circle, so using theta equals 2 pi, we're just simply going to substitute theta into our formula here for the area. So therefore the area of this circle, A, is going to be equal to a half times r squared times by theta. Okay, and remember theta is 2 pi, so this is 2 pi. Now here, if we've got a half times by 2 pi, that will just simply give us pi. So what we obtain here for the area is pi r squared. Okay, and we know clearly this result here gives us the area of a circle. So this concludes this Maths Made Easy video on the arc length and area of a sector.